Good evening, Dheeraj. Good evening, Muzamil, Muzaid, Ahmad. Good evening, Sairam. So let me wait for two more minutes. So let others to join. So share among your friends such that they will join. Good evening, Shivakumar. See here, Shivakumar. Hafiz, good evening. Shanti, good evening. Rushika, good evening. Deepika, good evening. So shall we start? Okay. Good evening, Deepak. Good evening, Sheikh Ilyas. So is my audio audible? Last time it was an issue with mic. Now is that clear for everyone? Let me know. Good evening, Sania. So coming on to my audio again, I am repeating. Is that clear? Thank you, Sania, for the confirmation. Thank you, Shiva. Thank you, Elias. Thank you, Rushika, for the confirmation. Thank you, Deepak. So I'll wait for 1 minute. I'll start at 6:56. So let us go through the topic one in big data. So I'll finish it by half an hour. I won't take much more than that half an hour because I'm not going for elaborative explanation. I'm just giving an overview how to write answer and how the questions will appear in examination for one topic, how differently the questions are coming from for the examination point of view, and that and also and I wanted to give an important note that we there is no one important question from 3 units. We need to go through every topic because as we are preparing 4 sets, it is impossible to give only some limited questions. Okay. So my perspective for you people is nothing but if you go through 2.5 units perfectly, then it will be very easy after mid two, and you can also score even good marks in semester because 2.5 units is completely new to you people. But whereas after 2.5 units, it is completely related to AML, deep learning. So which is nothing but already some are going with the deep learning in NPTEL subjects. And some are also known, like CV last semester, and also in the previous year also, you'll be you are going you have gone through some concepts in machine learning. So which means if you read 2.5 units, another 2.5 units is a bonus in big data. That is what the main advantage is. Okay, that's why what I suggest is that don't go for only preparing uh, important questions. Try to utilize, try to learn everything such that it will help in end semester exam. Try to score as much as you can in this particular semester. I was always suggesting, and now also I'm warning you people to go for only 10 CGPA. Don't go for 10 points in the every subject in the in the third year second semester. So don't only just go and write for pass marks. Okay. So let me go through the first topic. Okay. That is what the thing I wanted to mention. Good evening, Lahari. Good evening, Indra. So let me start the session. So the first topic of our particular syllabus is nothing but define big data. Okay. And then what are the 5 E's of big data? So you already know what are the 5 E's of big data, right? So the questions may be direct. Like what I suggest is that the question may come directly. 5 is they will give directly in question: velocity, variety, veracity, etc., etc. But uh, like what I suggest is that if a question comes regarding good evening, Meghana, if a question comes regarding uh, what do we say 5 E's, it may also include opportunities and drawback, the opportunities and limitations of 5 E's big data also. So that is the thing you need to go through. If a question comes regarding 5 E's, it is fine. You write all those things. If you look on the screen, you write about volume, you write about velocity, you write about variety, you write about veracity with examples. I am saying with examples. Okay. Because good evening. So value. So these are nothing but until this point, this is nothing but 5 E's. So, but what happens if a question comes regarding 5 E's is nothing but they may also ask you the limitations. Not that here, not I think here is the limitations. Not here. So I think so. If you see here, big data challenges. So big data challenges and opportunities along with the 5 E's. So the questions may be direct. For example, if in one set they may ask you the 5 E's directly by giving the headings itself directly, and they may also ask you 5 E's is not enough for your 10 marks, right? So they may also ask you the challenges and opportunities. Again, challenges are nothing but 5 E's are the challenges of big data. You write all those 5 E's and then you try to mention about data storage, okay, data processing, scalability, okay, and security, privacy. Okay, I will let me write here. So if you see on the screen, security, privacy. So these are the challenges of big data. Okay, cost. So these are nothing but the challenges of big data, right? So now if you only go through the opportunities of big data, so better for better decision making, it is good. Okay. And another thing is nothing but for customer personalization, big data is very good. And also business optimization. These are nothing but the opportunities of big data. If a question comes regarding 5 E's of big data, then they may also ask you the limitations of big data as well as uh, the opportunities in big data. For fraud detection also we'll be using big data, and for social and scientific benefits also we'll be using big data. So these are all nothing but the opportunities of big data. So earlier I was discuss the challenges of big data, and if a question comes regarding 5 E's, they may ask you define 5 E's, like they may give you the headings directly: velocity, variety, everything. And they may also ask you with examples, and they may also ask you the difficulties as well as the opportunities in big data. So that is the one thing if a question comes regarding this 5 is. And also in another way also they may ask you, Okay. In some other way also they may ask you, let me uh, they may also ask you like, what are the big data challenges related to storage? If it is storage, it is volume. If it is speed, another thing is veracity. If it is data diversity, so these, if a question comes in such a way, the same answer you need to write. Okay, the storage, speed, everything comes related to this five is. So you need to mention that things. Okay, and what I'm suggesting is nothing but you try to uh, if you try to go through the things, like what I suggest is that you try to go through the example that I've given in the class. Okay, I also explained in variety examples, like I haven't given a particular example that I prepared. I've prepared my slides, but I've given the examples according to you people answered. So that's why you go through the examples. Okay, I will share the PDFs, no issues, because I will share that. Let me now go through a quick recap. So the topic one is nothing but volume, veracity, variety. Huh? So this five is, so the five is may be asked directly or indirectly, like speed, okay, storage, data diversity. In such a way they may also ask you. But the same thing is again the answer is five is, okay. And also they may ask you like uh, variety, veracity, only two terms may be there, such that you need to write the five is again. If they only ask you velocity, it is not like only velocity I can write and come and I can ask for 10 marks. No. The thing is, they may ask you only one type, but the thing is, the agenda behind that is nothing but full topic. Okay. So we can't directly give you the five is every time in every set, right? So the thing is, the questions may be different. That's why I'm making I'm that the session is for only to people make you awareness about the questions, how they will ask question. Directly it may be, indirectly it may be. The answer is same. So in what I suggest is that initially I have mentioned three types of questions in five is. So one is nothing but directly they may ask, that is the direct question. Indirectly, that is nothing but volume. For volume, they may give you storage. For variety, they may give you speed. So such type of terminologies differ, but the answer is same. And another type also is nothing but they may only give you one particular topic, and they will ask they want you to they will expect you to write the full answer. So these are the things. So this is also one important question. Okay, this is the most important question I can suggest from unit 1. So and also one more question I can also suggest that from the second topic. So types of analytics, if you see this particular question, so they may ask you like directly. So descriptive, diagnostic, analytics, they may ask you, and they may give you the exact headings also. I'm saying about direct question, but indirect also, there is another scope of asking you what are the different types of categories of big data analytics. So if you see some terminology like big data analytics, if it is if you see that terminology in your question paper, try to attempt this question, types of analytics. Okay, so the thing is, we can't give in every set like uh, descriptive, predictive, such that. That's why it may also change. So I have discussed two types. One is directly it may give, indirectly it is nothing but types of analytics of big data. Okay. So this is one question from first unit, and also one more thing, that is nothing but Hadoop, which is the most important question from unit 1. But what I suggest is that you don't only learn this particular part. I want everyone to learn unit 1, unit 2 perfectly. Okay, you only try for 10 points in this semester in every subject, not only big data. Okay, don't only go for pass. You try to utilize this semester and try to improvise your CGPA. That is what I am saying in all the sections. If I am going for an NPTEL for AB and AB sections also, I am been saying that constantly. That's why what I suggest is that only try for 10 points in this particular semester. If your CGPA is below 7 per 7, it will be very difficult in these particular scenarios. So some are seriously wanted jobs. Their families are poor. So in that scenario, you need to improvise your CGPA. You need to improvise your everything. So that's why what I suggest is that you go for 10 points in this particular semester. Don't only go for pass marks. That's why what I am suggesting you, if I say any important, also you try to learn everything such that it will help you in the semester exam. So now another question, another topic is something but Hadoop. If you see Hadoop, so Hadoop may be directly asked question, okay? So they may ask you directly. For example, uh, let me give you one example how Hadoop may ask you. So, like they may give you apply, let us say HDFS replication. So HDFS or map reduce, if the terminology shows in the question paper, the architecture is nothing but Hadoop. Okay. The if I give any components also, you only write about Hadoop completely. Don't think only SAR gave HDFS or SAR gave map reduce. Okay. And also if they may also give you uh, I am also suggesting that if you learn Spark and Hadoop, you may, if any set comes, one question will be there compulsory. So Hadoop and Spark is mandatory. So you try to learn everything with base. You try to learn everything with examples such that it will be very easy. And you also draw the architectures. Okay, in the next lecture notes also that we have sent today, the all architectures are there. If you see here, for example, if a question comes regarding Hadoop, so this HDFS architecture is must. Okay. So don't neglect this HDFS architecture. So this is nothing but we'll be having name node, data node. So data nodes, this is how the data will be stored in racks. Okay. So data node also has replications. Okay. If this data, the main data is lost, it will be having replication. It will be stored in another rack. Okay. So that's why HDFS is very safe and secure. Whereas name node only stores metadata. Okay, if you see here, name, replicas, like this type of things, it will be stored. But whereas in data node, it will store actual data in racks, rack 1, rack 2, rack 3, rack n. Okay. So in rack 1, for example, if you see here in this particular diagram, so this is my actual data. But what if a question arises, what if my data is lost? So what HDFS do is nothing but it will be having replication. So in this replication, the data will be stored here also in another rack, such that if the one rack is gone, in another rack my data will be there. Okay, that is how this HDFS will be working on. So another thing is I can also suggest is nothing but let me see. Let me go through another. If you see here, so initially you are giving the file for HDFS, and then it will be going through map, and then in map reduce will be having three phases: map phase, shuffle and sort phase. Another last one is nothing but reduce phase. Next, after that, we'll be having combiner. Combiner is the sense you can directly write this reducer, no issues. And then so these are nothing but these are happening parallel. That is why you'll be having if you will be if you see here, that is why you are having so much reduce space, reduce task, reduce input. So these all are not necessary, but the thing is you can write all the diagram that I mentioned also. Very, I think I haven't mentioned the map reduce diagram. You can write this also, no issues. So for HDFS, you draw the diagram. For big data map reduce, you can draw this diagram. I think Sir also given some other diagram in their class notes I have been seen for A and B sections. They need to draw that particular diagram because you need to follow your instructor rules. So for particularly for my section, this is enough. Okay. And also for complete Hadoop architecture, this is nothing but this is resource manager. If you see here, so resource manager is responsible for allocating resources, right? So in resource man for allocating resources also, a one resource has node manager, container, app master. So they will be continuously updating the status of your task. Okay. So this is all. You can also draw this diagram if necessary. Okay, but it is not mandatory uh, for you people because I haven't thought in on your class notes. So this is also one important diagram that I can mention. Okay. Now, so if a question, if any question comes regarding these particular topics like map reduce, or if you see any type of these keywords, you try to mention everything. So you need to mention about every component. So here, from here the Hadoop definition starts. So you need to mention about HDFS and draw the diagram. Diagrams are mandatory. And then the components of HDFS have been mentioned here. So the components of HDFS is nothing but name node and data node. Name node is nothing but name node stores the actual the metadata, whereas data node stores the actual data. So this is what you need to write. And then in map reduce, I have been mentioned just now. You need to draw the diagram, and you need to say what happens in map phase and what happens in Stephenson sort phase and what happens in reduce phase. Okay. Then yarn. Yarn is nothing but yet another resource negotiator. So in this particular thing is yet yarn is nothing but yarn is responsible for allocating the resources for Hadoop. So and this also, you, if you prefer, I can prefer, if you want diagram, you can you can refer from the lecture notes which I have sent in the group. So components of yarn is nothing but resource manager, node manager. Okay, if you see the diagram, you will be able to understand. So resource manager will be there for yarn, and the node manager will be there. From they two will be communicating to each other. In node manager will be having container and app master. Okay. So the resource manager and node manager will be communicating to each other whether the task is happening or not, whether that for particular task the resources are provided sufficiently or not. So this is what happens in resource manager. And then at last, one more component I also mentioned, that Hadoop Common. So Hadoop Common is nothing but it is a utility layer. It contains all the libraries and utilities. So any question comes regarding HDFS, map reduce, you won't need to write all those things. Okay. So I think this is what about this particular topic. And one more topic which is left behind in this particular syllabus is nothing but NoSQL databases. If any question comes big regarding NoSQL database, or if you see some key terminologies like key value model, or let us say columnar model, or let us say another thing document model, you need to write all those things. From here you need to start the answer. From NoSQL you need to start the answer, and you need to write all those things until here document model, and then graph model. So you need to mention until here, until this point. Okay, if any question comes regarding NoSQL or any key value pair or columnar data, if any question comes, you need to mention all those things. I think this is about this topic. So they may ask you like, how they may ask you. Let me discuss also. So they may ask you like, what do you say? Directly they may ask you like, mm, directly one direct question, it may be like, what is NoSQL and what are the models of NoSQL. So these are the models of NoSQL. You need to write all those things. Okay. So this may also appear for 10 marks question. So because we are having four types of models, such that is why it may be also ask for 10 marks. So next thing is nothing but data lake versus data warehouse. Okay. So in this particular question also, will they may ask you directly data lake versus data warehouse. Okay. So I think there is nothing indirect in this particular thing. So wait, guys, let me answer a call. Hello, hello, సార్ చెప్పండి సార్. లేదు సార్, లైవ్ తీసుకుంటున్నది రివిజన్ సెషన్లో పెట్టినా కొంచెం. చెప్పండి సార్. అవునవును సార్. అవును సార్, అది స్పెషల్ రౌండ్ అది. నేను చెప్తా సార్ అది. ఒక 10 నిమిషాలని నేను ఫోన్ చేస్తాను సార్, క్లియర్గా చెప్తా. ఓకే సార్. సార్ అన్నీ చెప్తా సార్ నేను, అవి క్లియర్. ఓకే. ఓకే ఓకే సార్. So if you see, another question is nothing but lake versus data warehouse. So in this lake versus data warehouse also, it may be one direct question. So nothing is indirect in this particular thing. But as I mentioned, so indirectly they may ask you like by using different terminologies like OLAP, OLTP. I think we mentioned in the I've been mentioned in the class also. OLTP, OLAP. So you all, I think I mentioned, right? So OLTP is nothing but online transaction processing. So AP is nothing but online analytical processing. So these are nothing but this comes under data ware versus data ware Lego. So if any question it appears like OLAP, OLTP, the same answer. So don't be confused again. That is why I'm mentioning. Okay. This is about unit one. Still any doubts in, if you are having any doubts, let me know in the comment section now itself. So I'll go to unit two. So finish as early as possible such that we'll be winding up this session by 7:30. Still any doubts you are getting? Mm, Let me know, guys. Please make it fast in the comment section. Please answer. Till this point, is that clear? So if you are learning 5 E's of big data, you will also learn opportunities as well as challenges. This is mandatory. Thank you, Bhagat. Thank you for the confirmation. So they are mandatory. Don't neglect them. If you are learning Hadoop, then also learn the internal structure of Hadoop. So any question comes regarding MapReduce, HDFS or anything, the answer is nothing but Hadoop. Explain data lake versus data warehouse. Now, so data lake. So name itself has the answer. Okay. So data lake is nothing but the central storage system, which means it stores raw data. Lake in the sense every water canal will be joined in that lake. So it may be underground drainage, or it may be rainwater, or it may be some other water. So everything it stores. Okay. So which means it is not, it won't process anything. It only stores the data. Name itself has the lake. So in the lake everything will be present. Fish will be present. Snakes also live, and also crocodiles also live. Which is not nothing like only in this particular lake only fishes will be surviving, only snakes will be surviving, or only some other species will be surviving. That is not happening in data lake. So in data lake what happens is nothing but if I download one PDF that I don't know, that was sent in my group, I won't structure it. I won't keep in separate folder. It will be so. It will be same as it is in my download list. Same way, the data will be coming raw, which may be structured or which may be unstructured. Everything will be stored rawly. It won't store anything, especially like it won't modify that file name, or it won't modify section wise, or it won't modify it as structured. It just stores the data. So name itself has the data lake. Lake in the sense every water will be joining. As I mentioned, drainage water, rainwater. If some other water, some coming from another way, everywhere it will be everything. It will be joined. So it is not like we only want that specific water. But whereas data warehouse is nothing but it makes the data structured. That is what the key difference between data lake and data warehouse. And if you see here, so data it is generated without cleaning. Okay. So whereas data lake it supports structured data, it supports semi-structured data, it also supports unstructured data. So schema is applied when data is read. Okay, schema. I think schema I mentioned the definition also. So it is mainly used by data scientists. Okay. So data lake, it is mainly used by data scientists because raw data is coming in huge. It will be generated in your Instagram or in your Facebook, everywhere it will be generated, right? So it is coming structurally and unstructurally and also semi-structurally. So that's why what data scientists initially store this, where this data scientists initially store is nothing but data lake. So everything will be dumped in the data lake, and then they will extract the useful information using data warehouse. Okay. So now it works well with big data tools like Hadoop and Spark. Okay. So if you see the characteristics of data lake, I have been given some characteristics here. Stores data at very large scale. Okay. It is not like 1 MB or 1 KB. It is 1 PB, 1 ZB also. Okay. It gives high flexibility storage. So nothing. So any dump of data, I can dump in my data lake. Okay. It is not like only this particular preferred data we can only store. It is not like that. Okay. Data can be text format, images and videos, logs, and even also I mentioned JSON files and XML files. Okay. It is suitable for advanced analytics like and machine learning because for raw data I need to process it, right? That's why it is used for analytics. It can become dumb, been given here, data dumb if not managed properly. Okay. Example, if you see here, sensor reading is nothing but if you see the traffic signals, in that particular traffic signal, if someone is not wearing helmet, everything will be recorded. So if it is not arranged in sequence, so how can they find you, or how can they identify this particular person is not wearing helmet? So that is why data lake can be become data dump if it is not managed properly. That is why I've given here. So machine logs in the sense login, log over, log out, everything, images, videos. Okay, all data is dumped directly into data lake. Data scientists later decide how to analyze it. Okay, whereas if you see data warehouse is structured storage system, whereas this it can support any system. It may be structured, unstructured, semi-structured, but whereas data warehouse it only takes the structured storage system. It stores processed, cleaned and organized data only. If you take some data from data warehouse, it will be very structured. No, if some unknown people, if they wanted to analyze the data also, it will be clear. Okay. So it data follows data warehouse follows a fixed schema. Okay, before storage it mainly supports structured data. So schema is applied when the data is stored. It is used by business analytics because for business analytics they will require structured data. If it is messy, they cannot analyze it. That's why they require structured data. Okay. So it is designed for reporting and business intelligence. I think this is clear. It stores historical business data. Because okay, it stores historical business data. Data is well organized and consistent. That's already I mentioned, but I've been mentioning again here. Okay. It is more expensive than data lake. It is less flexible for schema changes. Okay, this is about data warehouse. I've been given some examples here. If you look here into the examples, a retail company stores sales data, customer data, and product data, everything. Okay. So schema is nothing but a blueprint. So been mentioning this particular word schema. So schema is nothing but it defines what it exists, like what name of the file, what is the data type of that for particular file, what is the relationship between data. So schema is nothing but uh, it is a blueprint. Initially, we will be creating a blueprint. This is how everything should happen. If I say I will plan a live session before your exam, this is my blueprint. So as per that particular rule, I need to follow that things. So here schema is fixed. So if you observe this particular point, uh, schema is applied when data is stored. So schema is fixed. That is something, but already the blueprint is fixed. But whereas here the blueprint is not fixed in data lake. Okay. So that is what about a data warehouse and data lake. Is that clear for everyone? Still, if you are having any doubt, let me know. No, right? Please let me answer me in the comment section. Make it fast, guys. Time is running out. So this is what about the data warehouse and data lake. So now I will be going on to unit 2, unit 4. Before going on to unit 2, let me give a quick recap. So quick important topics that may also uh, covered in your exam. One of the most important topic is nothing but Apache Spark. So Apache Spark is nothing but which is nothing but Hadoop was very slow. Why? Because Hadoop will be used in Hadoop will be using some language called Java. So in Java, if you want any word count, the every word will be mapped separately, every word will be reduced, so it is time taking process, and not only time taking process, we need to write a big Java code. If you see the experiment 3 that I have been uploaded the video also, in that video if you see, the code is very large, right? So to overcome that challenges, to overcome that type of complexities, Apache Spark was created. Okay, so whereas Apache Spark it will be having Kafka, which uses SQL queries. Okay, and it also supports Python, R, Scala, and even Java also. So which means it gives some flexibility for the users to use it, to engage with it. So but whereas Hadoop, it only works with Java. That is why it is traditional. So engineers who have been working like us, who they wanted one shortcut method, that's why they have created Apache Spark. Okay. So if you see here, Apache Spark, if you see the heading, I've been mentioned about these particular things. So let me discuss the architecture first. I think it is that. Uh, so if you see here, I think let me go through this. If there is any architecture, let me find out. So I think from this also they have been given good examples if you wanted. So this also having very good class notes in this particular PDF. If you see here, this is the architecture of Apache Spark. Okay. So this is driver program, and we'll be having cluster manager same as whereas in Hadoop we'll be having Yarn. Here in the cluster manager is responsible if one job is there. My job is to say to driver program. So let us say I want the students uh, to be I want the attendance of students, I want the attendance as well as marks as well as the fees dues of the students. So that is my task. So initially my task will go to driver program, and in driver program it will be having Spark context. In Spark context, that is what I mentioned here. If you see here, in Spark context, we'll be having Spark SQL, which gives the support of SQL. We'll be having Spark streaming, which means instantly if I upload attendance, you will be able to see your percentage. So we'll be having MLlib. Okay, MLlib also if you study in third unit, it will be clear here also. We'll be having another component called graphics. So graphics is nothing but if the data is connected, if the data is structured, we'll be using Spark SQL. If the data is if we want live streaming, will be using Spark streaming. If you want any analytics, okay, on the data, we'll be using MLlib. If the data is connected, every node is connected to each other, then we'll be using graphics. So these will be inside this particular Spark context. Okay. So these internally, these many things will be there. That is what my intention to show the diagram. Okay. So this is not actual Apache Spark. This is only the one component's internal components. Okay. And if you see here, cluster manager is responsible for giving resources as well as, whereas Yarn is only responsible for giving resources. But here cluster manager is responsible for giving resources as well as whether the work is done by node 1 or not, whether the work is done by node 2 or not, he is responsible. Cluster manager is responsible. If HOD gives some instructions to us, then us like cluster manager, we are responsible whether student has been updated the work or not. Okay, then we need to update. What we does is nothing but cluster manager will update to driver program to HOD. Your class teacher will update you to your HOD, as well as the student who has done the work will be updated to your HOD. So two persons here updating to HOD. So that is what happens in Apache Spark architecture. Same way. if HOD gives instructions to only class teacher, but class teacher says the works to students, even students will also go and update to HOD, as well as your class teacher will also go and update to HOD. This is what happens internally in Apache Spark. Okay. So if any question comes regarding Apache Spark, okay, you start writing from here. Okay, where I've been mentioned. So from start writing from here. You start writing from here and you draw the diagram. You can also draw the diagram that I've been sent today also. So you need to write about the driver program. So that driver program is nothing but it is like a brain of Apache Spark. Okay. So it controls everything. So it is responsible for sending jobs and receiving the task, output everything. So which it also maintains DAG. DAG we need to see. DAG is nothing but direct acyclic graph. Okay. So if you see here, if you want something regarding this particular task, it will be easy in Apache Spark. I want students who are less than 80 and I want them to group by a branch. I want to calculate the average. If this is my task in Apache, whereas in Apache Hadoop, I need to trigger out, it will map every student IDs, it will map every student names, it will map every student marks, and then based on the same number, for example, if my data is like I've been combined ABC sections, I haven't segregated anything, I have mixed ABC. Okay, what happens in Apache Hadoop is nothing but it will map everything A B C, again some ABC comes. Okay, again some ABC comes. You assume I may not able to write this. So what happens initially, it maps it and then it will filter out the similar terms. Okay, then it will be reduced. It will say, okay, you are having 2 years, so for 2 years I'll be segregating at once. But whereas here, if you write a simple SQL query, okay, so then it will be done. So that is why Spark is very flexible compared to Apache Hadoop, right? So now we'll be having this all those things. I'm not going all through the topics. So question, how the question will be appearing. So apply one more question also may appear from this particular thing is nothing but directly one question may come. So core architectural components of Apache Spark. So this means you need to write everything. So you need to mention everything with examples, such type of examples. Okay, you need to write about Apache Spark components driver program. In driver program, we'll be having Spark context. In Spark context, we'll be having these four types. You need to write a one point about this particular point, every component, and then you go for cluster manager, and then you go for these things worker node. So worker node, I am not given any class nodes. Worker node is nothing but worker node is responsible for executing, clearing cache, and to complete tasks. So you need to write one simple para about worker node. So that is enough. If a question comes regarding the only these things, only Apache Spark, that is enough. You should not mention about RDDs. Okay. So RDDs is completely a different topic. That is enough if any question comes regarding Apache Spark. So one more question may also like they may ask you like in different way. They may ask you by giving uh, the what happens by giving the component names. Same as where I mentioned in Hadoop, where they may ask you map reduce HDFS, but the answer is same. Here also the same thing may be triggering out. Okay, so they may questions may be anything. Questions you don't see so don't see the question. You just write if any question comes, if any component comes in the examination point of view, you write everything. So you need to write everything. Okay, so that is what that is how the questions may ask you in this particular topic. So whatever the question may be, so one more thing, if any questions for this particular topic only, they may ask you how RDDs help Apache Spark, and how what are the characteristics this you need to mention. Okay, and then you need to write about data frames, data sets also. So the questions may be, oh, if you see data frames and data sets, you start from RDDs. If you see any question that is having data frames and data sets, you start from RDDs. You try to mention what is Apache Spark, one architecture, and then you try to mention what is one line is enough. I won't say you need to write about elaboratively. One line is enough, and then you start writing from RDDs. Question may be anything. If you see any questions regarding data frame and data set, you try to write from RDDs until data frame and data set. You need to write all those things. These type of examples. This is mandatory. Okay. So someone texted me that I will share the class notes. Don't worry. Okay. So this is about this particular topic, and then they may ask you one more things like uh, differences between data frame RDDs and data sets also. So which may be directly in your examination point of view. Okay, right. I think this is what about this particular topic, and then moving on to Kafka. So if any question comes regarding Apache Spark real-time processing, you need to start from here. Okay, this you need to start from here, and you please write every this architecture properly. So let me explain again the architecture, okay, for your understanding. So producer is nothing but who sends, who updates your attendance. Myself is a producer because I am updating your attendance. So if I am updating your attendance, broker one will take care. If I am updating your mid marks, broker two will take care. If I am updating your, let us say, another thing, some other thing, broker three will take care. So internally, Kafka will be having brokers, and broker will divide based on topic. If the topic is about attendance, broker one will take care. If the topic is about marks, broker two will take care. If the topic is about fees, broker three will take care. So zookeeper is nothing but zookeeper who will be responsible to maintain all those things, whether all brokers are perfectly working or not. Then consumer is nothing but if I enter the data here, instantly the data will be visible here. So consumers are nothing but the students who will be seeing your attendance, okay, in the digital campus. So this is what about the Kafka. So Kafka, you can also write one more example. Let us say Uber. Uber instantly shows where the person is, where the how the person is moving, where the vehicle is coming exactly. Everything will be shown, right? So same way, so that they there where Kafka will be used. Okay. So you need to also write about all those things. So producers, what is consumers, everything that I mentioned here. This may also will be a Paka question. I may suggest you. So if any question coming Spark streaming Kafka means you need to write all those things. Okay, I think this part is clear, right? So and if any question comes regarding Apache Kafka, definitely there will be another question, that is nothing but pig and impala, pig and hive, or pig hive, pig impala. So only I think go for a hive pig as of now. Okay. So hive pig is nothing but hive and pig are used for overcoming the problem in Apache Hadoop. So that is what he had think mentioned here. So Apache Hive is nothing but it builds on the top of Hadoop. So Mm, please go through the class note that I've been given here. It is very easy. So Hive also having same as from language similar to SQL, that we call it as HiveQL. Okay. So you go through that. Okay. So I think this is what about the second unit. I think that is what will be there. Still anything left behind? Let me know from the second unit. So as of now, my suggestion is that you can go and overview with Apache Impala. You don't go much deeper for Apache Impala. Okay, but go through it. So I have given the uh, comparisons very clearly here. So if you see here, I've been given clearly it when Hadoop was created, when Spark was created. So this point, if any question comes separately in Hadoop also, please mention this particular only one point. I am not asking you to mention everything. You at least mention 1 and 2 points. Okay, this is much important. Then you try to mention everything that you have learned in unit 1 and unit 2. Okay, these are the differences that I have been given. Okay, if you want, you can go through it. And this is what about unit 2. This may questions are nothing but one is Apache Spark. Apache Spark. If Apache Spark comes, you need to write about the architecture. If Apache Spark for live streaming, you try to write about the architecture of you draw the architecture, just Apache Spark architecture, and then you mention about Kafka. That is mandatory. Kafka, you need to mention about the internal components of Kafka completely. There is nothing skipping, no skipping. You need to mention it clearly. Okay. If these two questions miss, another type of questions may come like differentiate between Impala, pig, and hive. And also they may also ask you uh, about Kafka. So this is the three typical questions, only three typical questions that are there from Unit 2. One is Kafka, one is Apache Spark, another one is Spark streaming for real-time analytics, another one is nothing but Pig, Hive, Impala. This is you consider these three topics as one question. Okay, these are the important things that are there from Unit 2. Is there any doubt in Unit 2? Let me know. Make it fast, and I will go to Unit 3. Guys, make it fast. No doubt. Thank you, Fazil, for thank you, Himalata. Thank you, Priyanka. So, if you see Unit 3, before going on to the types of questions that may be appear in Unit 3, I can suggest that from Unit 3, we'll be having only this syllabus. One is MLlib. So MLlib is nothing but which makes uh, our algorithms work on big data. ML algorithm, that existing algorithm work on big data. So that is what about MLlib and scikit-learn. You already know about scikit-learn. And another topic is nothing but data pre-processing. Data pre-processing is nothing but initially data comes and then we'll be using some data cleaning, everything, data transformation, everything. So and then it goes to feature selection and then model selection, and after that feature evaluation techniques, model evaluation techniques. Okay. So this is how data pre-processing works. So that is that same answer you write here. It is not like it is related to big data. You need to write about big data. Big data is nothing. So you use data pre-processing techniques in big data. That is what the topics are. How to use data pre-processing techniques. So we need to know how what happens in data pre-processing. So initially, if it is about ML libraries, so you try to write everything. So this is completely I've been repeated the sentence again and again. Okay. So I have been given very easy sentences here and there. So this is diagram is mandatory. So you don't skip the diagram. So if any question comes regarding MLlib, you need to draw the diagram. That is mandatory. Okay. Mm. So this is the diagram. If you see here, ML algorithms are three types. One is for predicting category, another one is for predicting quantity, another one is for predicting similarity. So in predicting category, you will be having labeled and unlabeled data. You know, unlabeled data means clustering you need to use. If it is labeled data, you need to use classification. If it is predicting a quantity, there comes regression. So it is, we'll be using ML dot regression in this particular big data language. And if it is about predicting similarity, basket based, user based will be there. This is not much important, but as of for your examination point of view, write this. So this is nothing but it is completely regarding reinforcement learning. So this is what about the architecture of MLlib. So I already given the working flow, everything that is completely theory point of view. You go through it. It is very easy. You think the theory is very prolongated, but the thing is very easy terms I have been used in the class notes. You can go through it. So moving on to the scikit-learn. So which is nothing but you already know scikit-learn is nothing but ML library in Python. So use it to build ML models. Okay. If it is nothing but it will be used on small to large medium sized data. Okay. So this is what about scikit-learn. So if you see here, the limitation of Scikit-learn cannot handle big data. So that is what you need to see, because Scikit-learn can't divide the data. Okay, it only process in one machine. But whereas big data works on distributed system, right? So it cannot be distributed. That's why Scikit-learn is not very much suitable for big data. So if you see another topic, data pre-processing. So initially data will be given, and then you will be creating new binary columns that will be required, and we'll be dropping the columns that are not required. If I want only attendance of the students, if in that particular data, if there is any marks, I will drop all those things. And if any missing values, okay, so I will be giving average, or I will be giving the least value or anything. So, and then scale the item MRP. And then I will be applying, I've been using some example here, random tree forest. Okay. Then at the last, prediction. So this is also one more diagram. So this is the diagram for ML pipeline. So if any question comes regarding ML algorithms, you draw ML pipeline as well as ML. If any question comes from ML lib, you draw the diagram for ML that I mentioned in ML lib, and as well as this. These two diagrams must, and you try to write the theory only limitedly. So you only write about MLlib algorithms that are there, that you already know, regression, Gani, you know, classification tasks, everything. So that if you go through the theory once, you practice the diagram. That is what I say. Even for A and B sections also, you practice the diagrams. It will be very useful. And for this is for, I think this is for data pre-processing. So you draw this diagram. It is mandatory. Okay. So, and in that pre-processing, what happens in each step I mentioned here. And this is about the things that is about related to data pre-processing. And this is supervised learning. You already know supervised learning has classification and regression. You try it as much as you can. For classification is nothing but I need to say whether this is apple or this is that is what is about the classification. Whereas regression, it is the value will be changing continuously. House price prediction. House price is nothing but the value will not be constant at this particular time. It may be some value at the same time. In for tomorrow, it may be changed, or maybe decreased, or maybe increased. But the thing is, the value will be changing continuously. Such type of task, you try to assume yourself. I have been given some examples in this particular class notes also. If you write all those things, machine learning, supervised learning, వచ్చిndante, you write all those things. Okay. So I've been given much matter, but the thing is, answer is very simple. Okay. So the questions, I will discuss the questions now from Unit 3, particularly from Unit 3. So from Unit 3, they may be asked you to uh, what happens how data for data pre-processing, they may ask you like future engineering techniques. Okay, instead of giving data pre-processing, they may ask you future engineering techniques. Okay. So future engineering technique is nothing but initially data will be coming, and then it will be cleaning, and then if missing values is will be, if any missing values there, you will need to fill all those things. So you need to write all those things. You need to write data pre-processing. So the diagram that is just now I mentioned, you need to draw this diagram. So the question may be like future engineering techniques will be there. If the terminology comes in that question, you only write about data pre-processing. Okay. And one more thing will be there. I've been not given the class notes. Okay. If any question comes regarding supervised learning, I want you to write the logistic regression and uh, linear regression. That is mandatory. Okay. That will be one other another question that it will be there from Unit 3. And even ML pipeline. If any question comes regarding ML pipeline, so you can draw this ML pipeline also. Okay. This is ML pipeline, and this also comes for data pre-processing also. For two questions, if you learn one diagram, if any set comes, this will be useful. Okay. And another thing is nothing but Scikit-learn. I think there is nothing indirect in this particular topic. You may get this direct question, which means that you need to write the answer that I mentioned in the class notes. Okay. And the last thing is nothing but if any question comes regarding regression or some other thing, regression classification. Any question comes, you need to write linear regression and logistic regression, mandatory. You write about supervised learning, you write about classification, and then you mention about regression and regression models. Okay. This is what about unit 3. Okay. This is what we will be having. Still any doubts? Let me know in the comment section and let us stop this live session. Guys, make it fast. If any doubts, let me know in the comment section. Clear, clear, everyone. Please let me know in the comment section. No, sir. Thank you, Hemalata. Thank you, Fazil. So, all the best for A and B, A, B, C sections completely. I'm okay. So, you gain 10 points in the big data and you boost your CGPA. That is what my suggestion is. So, I make sure that I've been cleared your doubts, everything, right? So, all the best, guys. So, thank you for joining, and I want everyone should show their talent in big data. Okay. I'm not particularly saying for C section. I have been saying for A and B, A, B, C. Okay. Thank you for joining, guys. Have a good day. So prepare. So I'm stopping the session.